Alright, welcome back. We are on number 60 now. This is part 10, day 2. So, rational functions is what this topic is going to, or these next few problems are going to be about. And you have to do several things for these problems. You need to state the vertical asymptote, or vertical asymptotes, horizontal asymptotes, x-intercepts, and y-intercepts of the given rational functions. So our first rational function looks like this. Now, we need to find all of the following. We need to find the vertical asymptote. We need to find the horizontal asymptote. We need to find the x-intercept and the y-intercept. Now, to do all of these things, to find the vertical asymptote, right, that is, right, if you imagine a graph, a vertical asymptote is a line that your function can't touch because at this x value you have some undefined value. So you're looking for places, like things you can plug into x that gives you an undefined value for a fraction here. And the biggest thing here on rational functions, the biggest way to find vertical asymptotes is to set the denominator equal to 0 and solve, because if the denominator is 0, that means you would be like dividing by 0, and that is undefined. So that is some value of x that if you were to plug it in, you'd get 0 down here, and you would have an undefined value giving you a vertical asymptote, right? So that's what we need to do. We need to find what x values give undefineds, and to do that, just set the denominator equal to 0 and solve. So we've got set bottom equal to 0 and solve. So let's go ahead and do that. So we've got x minus 2 equals 0, as we set the denominator equal to 0. You want to add 2, and you're going to get x equals 2. All right, there is your vertical asymptote. All right, so now we need to find the horizontal asymptote. And to do this, this uses the acronym Bobo Botan Eats DC. Right, so for this acronym, it's referring to the degree in the numerator versus the degree in the denominator. So the degree of a polynomial is the largest exponent of x, or your variable, in the polynomial. So you've got a 2 here as an exponent to the x. There are no other x's in the numerator, and there are no other, since there's no other x's, there's obviously no other variable, or in other words, exponents that are tied to the variables. So x squared is your biggest exponent on x, so 2. So the degree of the numerator would be 2. So if you're comparing here, like degree on top, that's 2. And the degree on the denominator, on the bottom, well, this is x to the first power, and it's the only x that's here. And so this has a degree of 1. It's the largest exponent on your variable. So on bottom, it's 1. So this is where this acronym comes in. If the degree is bigger on bottom, B-O-B, bigger on bottom, then you get y equals 0. That's the horizontal asymptote. If the degree is bigger on top, then you have none. And if the exponents, or degree, are the same, then you divide the coefficients. And these coefficients are the leading coefficients. So it'd be 1, because that's the leading coefficient up here, and 1, because that's the leading coefficient right here. But in this case, the top has a degree 2, the bottom has a degree of 1, so it is bigger on top, so we have none. So your horizontal asymptote is none. And that's because you're bigger on top, so you have none. All right, so moving on, you have x-intercepts. And for x-intercepts, you need to think about, like, I hardly memorize a lot of this stuff. I just sort of reason through it, and I've told you guys this whenever I taught it to you. So an x-intercept is some location on your function where it touches the x-axis. So if this was our function, it would have multiple x-intercepts. There would be an x-intercept right here, and right here. They are locations on the function that touch the x-axis. Now if you look here, all of these x-intercepts have something in common. The y value of all of these x-intercepts is 0. So it's some ordered pair where the y value is 0. All of these are some ordered pair where the y value is 0. Otherwise, they would not lie on the x-axis. So I know that all x-intercepts have a y value of 0. So I'm looking up here, and I'm thinking, how can I make this fraction equal to 0? And the way to do that is if the numerator is 0. Any time in a fraction when the numerator is 0, the fraction will be 0, excluding the possibility of the denominator also being 0. So what we want to do here is you want to set the denominator equal to 0, or not denominator, set the top equal to 0, or the numerator. Set top equal to 0, and solve. So we've got x squared minus 9 equals 0. This is a difference of squares. And I know that because x is being squared, so that's definitely x being squared. So that is a square. And then 9 is 3 squared. So when you're trying to solve a binomial here, where it is a difference of squares, you can use a difference of squares formula here to factor. And it works like this. If you've got a squared minus b squared, which in this case our a would be x and our b would be 3, it will always factor into a plus b times a minus b. And if you don't believe me that this works, we'll go ahead and do it, and then we'll factor it a different way. So this, as I was just showing over here, is 3 squared. So you've got x squared minus 3 squared. So this factors into x plus 3, x minus 3. Now, say you don't believe me that this is how you factor this, or it's something that's too difficult for you to remember when it comes time for you to know how to do this, right? Well, imagine it this way. We are so used to, at least in my class, factoring stuff that looks like this, like some number of x's, plus or minus some value here. So, and we think what multiplies to give you this and adds to give you this, right? Well, in our case, we've got x squared minus 9. So if you think about x squared minus 9, how many x's to the first power do you have? I don't see any x's to the first power. This is x squared, and you have one of those. And this is like minus 9 with no x's attached. So there are no x's. So that means there has to be 0 x's. And then if you think about regular old quadratic factoring, where your leading coefficient is 1, you think about what two numbers multiply to give you negative 9, add to give you 0. Well, that is a plus 3 and a minus 3. Those multiply to give you negative 9, and they add to give you 0. And so this is what you get. And it's the same thing using the formula. So a difference of squares will always work this way, where you think of it as 0 x's, and it'll always factor out this way. Anyway, after we factored, this is all still part of the solving. You have to factor, and then you set each factor equal to 0 and solve. So you set x plus 3 equal to 0 and x minus 3 equal to 0, and you solve those. So you're going to add 3 in this case and subtract 3 in this case, giving you x equals -3 and x equals +3. And so you could say that that's x equals plus or minus 3. Now, for you regular Algebra 2 students, I'll probably accept this as a viable answer. You clearly have understood the idea of the steps to get the x-intercept. However, don't expect that slack in my pre-AP classes. Intercepts are ordered pairs, right? They're places that touch the x-axis on a coordinate plane. So they should be presented in ordered pairs. So if the x value is -3 and +3, remember the y value had to be 0. So you would get 3, 0, and -3, 0. Those are your x-intercepts, right? So here we've got our x-intercepts. All right, moving on. Look at y-intercepts. So y-intercepts are places, if you looked at this function here, this hypothetical function, places where you touch the y-axis, so right here. And something in common for all y-intercepts is that the x value in the ordered pair is 0. So you get some value of y, whatever it is, but the x value has to be 0. So the thing you need to do is make x equal to 0. So looking up here, all you're going to do is you're going to plug 0 in for your x's. There's 0 minus 9 and 0 minus 2. So that's what you do. You plug 0 in for x. All right? So you're going to get 0 squared minus 9 over 0 minus 2, which gives you, and that's what y equals, which gives you -9 over -2, which is 9 over 2. Now again, these need to be in ordered pairs. So if you plugged in 0 for x, that's 0, 9/2. There you have it, your 4 main things for rational functions. Now let's go ahead and move on to the next problem, and let's try to speed this up a bit. So we've got 61. And that is y equals x squared minus 9x plus 20 over 2x squared. All right, so let's get back to it. You've got vertical asymptotes. That's where you set the denominator equal to 0 and solve. So you want to divide by 2, and you're going to get x squared equals 0, because 0 over 2 is 0. And then to get the squared to go away, you square root, and you remember plus or minus square root on the other side. And you're going to get x equals, in this case it would be plus or minus the square root of 0, but the square root of 0 is 0. And so it doesn't matter if it's plus 0 or minus 0, it's still 0. So the vertical asymptote is at x equals 0. This, you might be asking yourself, well, why don't we have to make a ordered pair for this? Well, that's because this represents a line, a vertical line on a coordinate plane, not a specific point. All right, so if you plugged in 0, you would get 0 in the denominator. That's an undefined value. So we can't use that value for x. All right, horizontal asymptote. That's your Bobo-Bodden eats DC. And if you look here, the degree of the numerator is 2. It's the largest exponent on x. And the degree of the denominator is also 2. So, in this case, we are at eats DC. The exponents are the same. So you divide the coefficients. So the leading coefficient is 1 on the numerator, because there is 1x squared. And in the denominator, there are 2x squareds. So you get y equals 1 over 2. And so there is your horizontal asymptote. I'm going to get a drink real quick. X-intercepts come next. You can do these in any order, I really don't care. So, x-intercepts. All right, scroll back up here to see what we do for those. You set the top equal to 0 and solve. All right. Set the top equal to 0 and solve. So that's x squared minus 9x plus 20 equals 0. This is a standard case of what multiplies to give you 20 and adds to give you a negative 9. So I'll go into this a little bit. Students oftentimes have trouble factoring basic quadratics like this, and it's because they don't have in their head a good sense of the factors of 20, or the number that's here. Right, so a strategy that I encourage you to use is to just start thinking about all of the factors of 20. So, and by that you want to start at 1, so 1 and 20, and you want to compare 1 and 20. If you made one of those positive or negative, and the other one positive or negative, could you possibly get negative 9? Well, these are 19 units apart, even like if this one's negative, or this one's negative, right? So these are 19 units apart. There's no way you're going to get 9 out of that. All right, so then we look at 2 and 10. So you were closer to 9, but if they were both positive, you would get 12. If they were both negative, you'd get negative 12. If one was positive and one was negative, you'd get either positive or negative 8. So not 9. 3 doesn't go evenly into 20. 4, though. We got 4 and 5. Now, 4 and 5 can combine to give you 9. Right? So then this is a good thing. Right? 4 and 5 can combine to give you 9. So that's typically what you're going to be using. Right? So you're looking, how can you make a positive 20 when you multiply something, but a negative 9 when you add them? Well, they'll both have to be negative. A negative 4 and a negative 5 make a positive 20, and a negative 4 and a negative 5 will add to be negative 9. So that's how we do it. So you've got x minus 4, x minus 5. Set each factor equal to 0 and solve. So your x-intercepts are 5, 0 and 4, 0. It doesn't matter what order you put those in. Y-intercepts. For y-intercepts, you just plug in 0 for all your x's. And we're going to have a problem here. If you try to do that, notice how 0 creates, like if you plug in 0 for x, you get 0 here. That's a huge problem. There's there's a vertical asymptote here. So that means there's not going to be any y-intercepts. And if you just did it manually, 0 squared minus 9 times 0 plus 20 over 2 times 0 squared, you would get 20 over 0, which is undefined. So in this case, there are no y-intercepts. And there you go. Done with that problem. I think there's only one more in this grouping, and we'll go ahead and stop after that. I didn't think these 3 problems would take so long, but, what do I know? So, 62. Y equals x squared plus 12x plus 20 over 4x squared minus 9. Alright, this introduces some new ideas in here. So your vertical asymptote, that's where you set the denominator equal to 0 and solve. Well, your steps for solving are to add 9, and you're going to get 4x equals 9, and now you have to divide by 4, and so you're going to get, forgot my squared. You get x squared equals 9 over 4. And then here, to get rid of the square, you need to square root. And you remember the plus or minus square root. And a lot of students will want to leave it like this, as x equals plus or minus the square root of 9 over 4. But you can apply the square root to the top and the bottom. So you've got square root of 9 over the square root of 4, and that is 3, and this is 2. So it's 3 over 2. All right, so there is your vertical asymptote. You have two of them, one at x equals positive 3 halves and one at x equals negative 3 halves. Okay, so horizontal asymptotes, that is Bobo-Bot needs DC. Notice that your degree is 2 and 2, so you divide the coefficients. So you take y equals 1, because that's the leading coefficient up here, over 4, because that's the leading coefficient right here. Simple as that. X-intercept. So for x-intercepts, this one's always more difficult for me to remember for whatever reason. But you're going to set the top equal to 0 and solve. And so here you're going to factor again. Factors of 20 that add to give 12. Well, let's scroll back up here. We did 20 already. If you look here, 2 and 10 can add to give you 12. So that's the ones we're going to use. So x plus 2 and x plus 10. Set each of those equal to 0 and solve. And then write as ordered pairs. Alright, y-intercepts. And feel free to pause the video. I'm sure you've been doing this, but feel free to pause the video if you need to work stuff out alongside me and I'm going too quickly. I've just already explained all this, so surely you can see what's going on. Alright, y-intercepts. That is where you plug in 0 for all your x's. So you've got 0 squared minus or plus 12 times 0 plus 20 over 4 times 0 squared minus 9, giving you 20 over negative 9. And that is equal to y, right? Because this whole thing was equal to y. So your y value is negative 20 over negative 9, and so you've got 0 for x, negative 20 over 9. And there you go. There are all of your things you're looking for. You've got your vertical asymptote, your horizontal asymptote, your x-intercepts, and your y-intercept. Alright, hopefully this has been helpful. Thank you all for watching and checking your answers. Hopefully you guys stick around for the next part.